Hello, so for oral exam number 2, question 1 asks why the integral of 0 to 2 is an improper integral. So we see it's a type number 2 improper integral, but why? Because f is continuous on the closed interval of a to b except at c and a to b, then the integral of a to b f of x dx equals the integral of a to c f of x dx plus the integral of c to b f of x dx. Okay. So using this integral right here, right, plugging f of x into it, we're going to change these bounds to 0 to 1 and 1 to 2. Because if we look into 1 and 2, 1 here is not defined. F is not defined at 1 and 0 to 2. Why? We can see this by plugging 1 into x. So we have 1 over 1 minus 1 squared equals 1 over 0. And you can't have 0 in a denominator of a fraction. It's undefined, so it's improper. So for number 2, it's asking why the integral of 0 to 2 is convergent or divergent. So we want to solve for that. So we have this integral right here that we're working with. So with the integral of a to b f of x dx, the limit of t to b to the left is the integral a to t f of x dx. So we're going to take out, we're going to substitute this t in for the 1 right here. And we're going to keep the 0, and we're going to have the limit of t to the 1 to the left, okay? So to solve this integral right here, we need to do a u substitution. So we can do a u substitution for x minus 1. And since we do a u substitution, we're going to have to change the bound. And for u, du would be just dx. And to change the bounds, we're going to have to plug these in for x. So we have t minus 1 for the upper and 0 minus 1, which is just negative 1 for the lower. So we have the limit from t to 1 to the left, and the integral of negative 1, t minus 1 over u squared du. And so to rewrite and to take the integral, we have this, and then we have to plug in our new bounds that we just got into u, and after we do that, we get over here. So when we have the limit of t to 1 to the left, we see here that we get negative 1 over 1 minus 1 minus 1. And we see that this over here goes to infinity, minus 1 is still infinity. And note that it's convergent if the limit exists, otherwise it's called divergent. And since this does not exist, it would be divergent. And for here, we're just finding out if it's convergent or divergent for the integral of 2 to infinity. So we're going to be using this formula right here. If the integral of a to b f of x dx equals the limit of t to infinity and the integral of a to t f of x dx. So we're going to substitute this t in for our infinity right here to take the limit, and the t will go to infinity here. And same thing here, we're going to do a simple u substitution. And we can do that for x minus 1 here, and then du is 1 dx. And we change the bounds again, so plug in t for x, so t minus 1 is for our upper, 2 minus 1 is just 1, that's for our lower. So the limit of t to infinity is the integral of 1, t minus 1, 1 over u squared du. We're going to rewrite and then take the integral of that, and then we have to plug in our new bounds right here into u. So after we do that, we see that limit of t to infinity, we get negative 1 over infinity minus 1, and we see that this graph goes to 0 plus 1. So 0 plus 1 is just convergent, right, because this 1 exists, so it will be convergent.